In the last lesson, we looked at level 1 and 2 strategies, and in this lesson, we're going to extend that into discussing level 3 strategies. The different strategies or methods, level 1, 2, and 3, are discussed in the appendix of the Common Core progressions, and that is written by the Common Core team. When students develop number sense and a repertoire of level 3 strategies, they're able to apply flexible strategic thinking, converting a problem to an easier one by taking advantage of number relationships. Of course, this strategic development doesn't happen overnight. Many aspects of math instruction and experience lead up to this moment where children begin to try level 3 methods. Their work with level 1 and level 2 strategies is critical in helping them make sense of problems, building number relationships, and beginning to abstract those relationships. And their work with part-whole relationships both in kindergarten and in first grade is also critical to their ability to get to the point where they can apply level 3 methods, such as the Make 10 strategy. Additionally, the choice of strategy in level 3 is often based on the particular numbers involved, requiring them to think about what they know about those numbers, as well as what they know about how numbers behave, how they operate, and what that implies for how they can be manipulated. In other words, there's quite a bit of sophisticated understanding about number. That understanding doesn't just happen. It is developed through their work with level 1 and level 2 strategies and part-whole relationships. Level 3 strategies, as I mentioned, are also known as convert to an easier problem. Here you see how children can use a known fact, which is usually based on making 10 or on a doubles fact they know, and they can use that to convert an unknown arithmetic fact into a known one. Although children really have to think about these relationships initially, they get pretty fast at it. It typically takes much longer for a child to communicate how they solved it than it actually takes for them to solve it. Although we are primarily discussing problem solving right now in this PD module, you will see that level 3 methods are clearly related to the development of arithmetic strategies and fact fluency. In 2008, Henry and Brown conducted a study with California first graders after the state passed a mandate that all first graders must learn their basic addition facts. Henry and Brown explored to what extent that happened and what kinds of instruction was occurring to get it to happen. One of the interesting findings showed that classrooms that fostered level 3 methods outperformed those classes that used traditional time tests and flashcards to build fact fluency. The next chart might shed some light on how that actually happens. Here you see all of the addition facts that first graders are expected to master. Essentially, you can see by the color coding that instead of memorizing a multitude of facts individually, they essentially just need a small set of level 3 methods in order to competently learn all of these facts. The green facts are simply level 2 counting on facts. If you only have to count on 1 or 2, then counting on is very efficient. The red and orange facts are based on making a 10. The red facts are just a known fact of 10 with a plus or minus 1 strategy. So, for example, 5 plus 4 is like 5 plus 5, except it's 1 less. So I could use that. So it's just an adjustment for a plus 1 or a minus 1. Those that are in orange are also involving making a 10, but they use a strategy called compensation so that we sort of borrow from one of the addends to turn the other addend into a 10. And then we have a 10 and a leftover. The blue facts are doubles combined with a plus 1, minus 1 strategy. And the yellow facts are simply understanding the teen numbers as a 10 and leftovers, something that was actually addressed for the first time in the kindergarten Common Core. Now, a couple of comments about this chart. There is actually more than one way to apply a level 3 method to some of these facts. For example, 6 plus 7. 6 plus 7 lends itself to a doubles plus or minus 1 strategy. But you could also decompose the 6 into a 3 and a 3, give one of the 3's to a 7, and turn the whole problem into a 10 and a 3. That's possible, and different students might choose different level 3 methods for a particular fact. If you have taught these facts primarily through memorization, and the idea of fostering these strategies is new to you. It probably seems a bit overwhelming to think that you could get first graders to use these number-based strategies. There are certainly ways to foster this kind of thinking, and we will be looking at some of those next week. I also look forward to hearing your own ideas in the discussion board about how you are actively fostering Level 3 strategies in your classroom. Counting and making sense of mathematical situations that were highly contextual was a big focus in kindergarten. In first grade, this is extended into thinking about how numbers are related to one another, how they behave when we operate on them. Two properties that will be very important for them to learn are the commutative and associative properties. However, the Common Core authors have been very clear that children do not need to know those properties by name. They need to know the idea, what it really means about how numbers behave. They don't need to know the name commutative or associative. Those names, however, commutative and associative, are useful for our teacher talk. So we're going to be using them between us, but it's really more essential that the children get the idea of it rather than the term. The commutative property is simply that the order of the two add-ins is not important. If we have 3 items and add 5 more items, we will have the same total that we would get if we started with 5 items and then added 3 more items. It's important that children are not merely told this, but that they try to make sense of why this is true. And it should come up more than once. It shouldn't just be one lesson on commutative. When you see that it comes up and that somebody's taking advantage of it, that can become a good point of classroom discussion. Problem solving is a really good place for this issue to come up. You can actually give students a set of paired problems. Basically, the problems are practically identical, even in wording, context, structure. The only difference is that the add-ins are switched. You can have students predict what they think will be the case. Do you think that the first answer will result in a total that is more, less, or the same as the second problem? And why do you think so? This can allow you to actually get at the mathematical standard of practice 3, where children are encouraged to reason quantitatively and justify their thinking and critique others' thinking. They can then solve the problem and have a group dialogue about what happened and why they think their totals were the same. And then, this is important, they can be challenged to consider whether this would always be true. I like to have a fictional student sometimes that I refer to. It's a little safer that way than picking somebody from the class always. And so I can say, well, I know this kid Lloyd, and he thinks that maybe this only worked with these numbers, but maybe it wouldn't work if we had different numbers. What would you say to Lloyd? The associative property allows us to add more than 2 add-ins, so we're adding 3 or more, in more than one way. We see that adding 5 plus 8 first and then adding on 2 results in the same total that we would get if we added 8 plus 2 first and then added on the 5. However, not all combinations are equally easy to solve. You can try to give children word problems where there are really some advantages to being thoughtful about the order. When children use different approaches, then you can have a strategy to share about why they resulted in the same answer, but you can also then have them explore the idea of which combinations were the most efficient for solving the problem easily. I already mentioned some ideas about using problem solving to introduce the idea of the commutative property, but I also want to talk about some of the distinct advantages to using this property of addition. You might remember that in a previous lesson we discussed start unknown problems, and we mentioned that they are extremely difficult for children. As it turns out, if children really understand how numbers behave, they can restructure this problem into an easier one. For example, I could normally not count on with a start unknown problem because I don't know what number to start counting on from. But if I recognize that the add-ins are actually interchangeable and it won't affect the total if I switch the order, then I can just choose to start counting on from the change quantity rather than from the start quantity, and that will also work. Now, this is not something that will make sense to a child who is primarily operating at level 1, though, because level 1 children are really attending more to the story context than they are to number relationships. So they need some more experience building number relationships before they could ever comprehend why that would be true. Although the relationship that I'm describing here about restructuring a problem can seem pretty obvious to adults, that I could start counting, like in question mark plus 3 equals 5, I could go 3, 4, 5. That relationship is obvious to adults, but not necessarily to first graders. It's a big mathematical idea to them. So don't expect to just be able to tell students, oh, the order can be switched, and then expect them to just start using that information in problem solving. It isn't that easy. They need to construct this understanding and really grapple with it. The idea of this property of addition needs to come up repeatedly in appropriate and varied contexts so that children have the opportunity to make sense of it over time. As I mentioned earlier, the associative property is likely to come up when you give children word problems that involve 3 addends, which is Common Core OA Standard 3. Be thoughtful in how you write the word problems so that children who simply follow the order of the problem are actually at a slight disadvantage over those who are strategic in which 2 numbers they should add first. Like this problem. To add 7 and 6 and then add on 4 is not as strategic as saying, I'm going to take my combination of 6 and 4 and make that into a 10. The whole problem then turns into a 10 and a 7. So intentionally word your word problems so there are distinct advantages to being strategic, and then that can actually show up in an interesting dialogue during your strategy share time about whether both ways resulted in the same total and whether one way has any advantages or not over the other way. Although the commutative property involves 2 addends and the associative property involves 3 addends, when you take the 2 properties together, it actually generates a third property that you can call the any order property, which basically says that if you have many addends to combine, that actually you can do it in any order, so you can be very strategic. Provide opportunities then for children to solve problems with not just 3, but perhaps even more addends so that they can get some practice in looking for ways to be strategic in how they combine the numbers. Your children can explore properties of addition through a variety of problem-solving experiences. Some problems are naturally embedded in the children's literature that you may already be using. For example, the book Counting Crocodiles that you see here is a book that learners will love. It is written in an engaging rhyme, and it features a pretty wily monkey who manages to get the best of the crocodiles. The story has a counting pattern that builds. After reading it through one time, you can suggest that they try to find out how many crocodiles there are altogether. Consider having them make predictions and give reasons for their predictions so you can build in some mathematical standards of practice. And then read the book a second time to collaboratively generate the number sentence that you see in the orange box. Children can then be challenged to find ways to add up these numbers to figure out the total. It is considerably more efficient for children to find strategic pairs than to just simply add the 1 and 2, then add on the 3, then add on the 4. That will make the problem considerably more difficult. However, really open this up and allow the children to solve it in ways that they see. Encourage them to find some strategic ways, but don't suggest necessarily pairs. And allowing for that diversity of approach gives you a more interesting strategy share that can particularly focus on some critical ideas. And that is that the numbers can be added in any order. So it gives you the fact that there's such a variety, and that those that are done accurately will all result in the same total, helps children understand that they can be added in any order, and that some orders are more efficiently solved than others, and that it would be wise for them to search for strategic combinations. Now that we've discussed properties of addition, we're going to come back to the Level 3 methods of converting to an easier problem. The Level 3 methods are based on properties of addition. When children develop meaningful arithmetic strategies based on number, they're also further developing and solidifying their understanding of properties of addition. They're also developing their understanding of number by learning how to decompose and compose numbers. It's hard work to develop these strategies, but this hard work comes with a huge payoff, and that is their increased understanding of mathematics and number sense. The Level 3 strategies for addition typically involve children using an anchor fact, typically a sum of 10 or a doubles fact, and then using that fact to generate a strategy for an unknown fact. The next slide is review. But it is important for us to unpack all of the prerequisite skills that we need in order to, children need in order to pull off that kind of strategic thinking. So children need to have a set of anchor facts at their disposal. This is a set of well-known facts. Fact fluency is a primary topic in a different PD module, and it deserves more attention than we can give here. But I will say that I focus first on counting on 1 and 2, and then after that, the facts that I most frequently emphasize are the anchor facts I want them to have, the sums of 10 and the doubles facts. And I do that primarily through games. And I also am very intentional in trying to get students to figure out how to leverage that information. Some of the games that we use to build anchor facts are going to be included here in the teacher resources. Children also need to be able to decompose numbers readily. It won't help them to know that 7 plus 3 is 10 when they see 7 plus 4, unless they realize that they can decompose that 4 into a 3 and a 1. Related to this idea is that children need to recognize different problems can be decomposed in many ways, but that typically there are fewer good options for decomposing a number in a particular problem. For example, 7 plus 4. It works well for me to decompose the 4 into a 3 and a 1. It wouldn't be all that helpful to decompose the 4 into a 2 and a 2 in this situation. Finally, level 3 methods are most useful for the arithmetic facts that result in teen numbers. So children need to understand that teen numbers are composed of a 10 and leftovers. When they see the 14, they need to think of it as a 10 and a 4. And when they see 10 and 4, they need to think of that as 14. All of these prerequisite skills are part of the kindergarten Common Core, but I'm sure I don't have to tell you that these skills will likely need some ongoing work to ensure that they're in tip-top shape if children are going to be able to leverage these skills in becoming strategic about arithmetic. This is just an example from the previous slide, but it shows the kind of thinking that children do. As you can see, it looks almost painful, the amount of thinking for each step along the way, but it will amaze you when children get practice developing strategies, how quickly their mind can do this. I mentioned earlier that children typically use two kinds of anchor facts when they are converting to an easier problem. They either use a sum of 10 or else they use a doubles fact. If you remember the color-coded chart that I showed earlier in this presentation, you will notice that sums of 10 are actually more versatile than the doubles facts. You can use them to generate arithmetic strategies for a broader array of number combinations. However, in my experience, I often find children naturally choosing to use doubles facts to convert to an easier problem before they use the sums of 10. Typically, I go along with that, under the assumption that learning to be strategic with the doubles is good practice for learning to be strategic with using the sums of 10. However, I also look for ways to actively encourage using the sums of 10. One of the ways to do that is by the number combinations that you choose for word problems. You can choose number combinations that lend themselves to that particular strategy. In this PD module, we are primarily interested in the development and application of level 3 strategies in the context of problem solving. Therefore, it's important to remind ourselves that children will not be able to generate these kinds of strategies if they really can't even get past the comprehension of the word problem. So that's going to be the topic of our next lesson. Children also need excellent part-whole understanding with its associated capacity to decompose and compose numbers in a variety of ways and to be able to choose which of those decompositions makes sense in this situation. The sums of 10 and doubles need to be actively developed so that they are available in the schema when developing level 3 strategies. And I mentioned that I'll have some games in the teaching resource section, and I hope that you'll share some of your own ideas about that as well. Finally, level 3 methods are based on the properties of addition, so children need to have significant and meaningful opportunities to explore how numbers behave. I've included a few ideas for doing so in this presentation, and again, look forward to hearing some of your own ideas in the discussion forum. If you were interested in the Henry and Brown study that I mentioned, which showed that fostering level 3 or derived fact strategies was more effective in